derive the supply curve for a competitive market, it's important to understand how firms in competitive markets maximize profit. We said earlier that profit maximization happens at the quantity where marginal revenue equals marginal cost, so let's see what implication this rule has for firms in competitive markets. In the introduction to competitive markets, we show that the demand curve that an individual firm faces is perfectly elastic, or horizontal. This is simply because in a competitive market, each firm can sell as much as it reasonably wants to at the prevailing market price, and the firm doesn't have to worry about lowering its price in order to attract more customers. Because of this, the extra revenue received for each additional unit sold, aka marginal revenue, is just equal to the market price. For example, if the market price of my firm's output were $6 per unit, I would be bringing in an additional $6 of revenue for each additional unit sold. You can see here an example of this. If I were to sell 0 units, my total revenue would be 0. If I were to sell 1 unit, my total revenue would be 6 times 1 or 6, and so on and so forth. Here, by calculating marginal revenue, or the additional revenue for each extra unit, you can see each time I increase quantity by 1, I increase my total revenue by 6. So we can see that marginal revenue is consistent at $6, which is what I said was the hypothetical market price. So we can see here that corresponds to this curve here, where we can say that this horizontal line facing an individual firm represents either the demand curve or the marginal revenue curve. It's always true that in order to maximize profit, firms want to set their optimal quantity where their marginal revenue is equal to their marginal cost. That's just always true. In competitive markets, however, like we just said, we can show that marginal revenue is just equal to the market price. So if we were going to substitute this equation here into this profit maximizing condition, we could say that in competitive markets, we want to set our optimal quantity, or our Q star, at the point where price is equal to marginal cost. Graphically, that's very simple. Notice that I've drawn in a typical marginal cost curve here, and we could just show that we want to produce at this Q star where our market price intersects our marginal cost. If our firm has an upward sloping marginal cost curve, we can show that as our price increases, our firm is going to want to produce more, and as our price decreases, our firm is going to want to produce less. So we can see here, P1 star was just the first line that I showed you earlier, and we said at this price equaled marginal cost at this intersection point here, so our firm wanted to produce a quantity Q1 star. Now, if the market price were to increase to P2 star up here, now the intersection of price and marginal cost is up here, and that corresponds to a quantity of this Q2 star here. So we showed as price went up, the profit maximizing quantity also went up. Conversely, if we were to consider a price decrease from this P1 star here to this P3 star down here, we would see that now price intersects marginal costs here, which corresponds to a quantity, not surprisingly, labeled Q3 star. And we can see here that a price decrease from P1 star to P3 star corresponds to a quantity decrease from Q1 star to Q3 star. So you can think about whenever you have this traditional upward sloping marginal cost, that higher prices induce firms to produce more and lower prices induce firms to produce less. Once we know the market price, how much the firm is producing, and the firm's cost structure, we can even get fancy and show how much profit the firm is making. So here, just as a refresher, again, profit is equal to total revenue minus total cost. Or, just with a little bit of mathematical manipulation, we can say that profit is equal to quantity times price minus average total cost. And we said before that this quantity was equal to the area of a rectangle where one dimension was quantity and the other dimension was price minus average total cost. So we can think about how that applies to our picture over here. Again, if we said that the market price was at this P star, we said that demand was equal to marginal revenue. We say, well, in a competitive market, our profit is maximized where price equals marginal cost. So that's just here. We've got price. We've got our marginal cost curve. That just corresponds to this quantity, Q star. In order to think about profit, we not only need to look at marginal cost to determine quantity, but we need to look at average total cost. So I took the liberty of drawing in an average total cost curve here with a typical U shape, etc. And we can see that we can actually find this rectangle that we were talking about. We can say we can draw a rectangle such that the height is just price minus average total cost, which is this guy here, just the difference between price and average total cost at the quantity that we're producing. We can connect these two dots. We can get price minus average total cost. And now we can continue making a rectangle by extending this to the left. We get something that looks like this. So the width of our rectangle is just our quantity, because we're just going from a quantity of 0 to this quantity out here. And we can see that this rectangle that we've created, in fact, represents the amount of our profit. One important thing to keep in mind, just because it gets a little bit confusing, is oftentimes this distance will look like it's intersecting the bottom of the average total cost here. But that's actually not the case when we're producing over here, so you just want to be careful that you're not mistakenly making your rectangle intersect with this point down here. But we can see that we pretty simply get this rectangle that corresponds to this quantity that we were talking about here. And we can see that if the price is all the way up here, the firm is in fact making a positive economic profit. It's entirely possible for a firm to be making a negative economic profit in a competitive market, and we can represent that on our graph as well. Just as a reminder, losses are just equal to negative profits, and graphically we can say that this is almost the same as our profit rectangle here, because our horizontal distance is still our quantity produced. But in this case, the height of the rectangle is average total cost minus price, as opposed to price minus average total cost. So we can show this on our graph as following. We can say, even if the firm is going to make a loss, it can still maximize its profit by minimizing its losses. You know, think about it, you'd rather lose $3 million than $10 million, right? So it's still true, even when a firm is making losses, that it's going to be doing the best that it can by producing at the point where price is equal to marginal cost. And we can see in this particular diagram here that price intersects with marginal cost here. And this firm is going to want to produce at this quantity Q star. We're going to come back in a minute and talk about the shutdown condition, but for now let's just assume that the firm does in fact want to produce, and the best that it can do is to produce this amount Q star. So if it's producing this amount here, again we bring average total cost into the picture, and we can put this rectangle on this picture over here. So again, we can show this distance of average total cost minus price as just the vertical distance between average total cost of the quantity we're producing and the price. And then we can show our horizontal distance of our rectangle by just extending to the left, so that we have the width of our rectangle being the quantity produced. And now this rectangle here is representing our economic losses in this competitive market at this price. We can even see that profit can equal 0 in a competitive market. And you'll see here, notably, if our price is equal to our average total cost at the quantity we're producing, then price minus average total cost is just going to be 0. And therefore, our profit is in fact going to be 0. Graphically, we can see that that happens at this point here, because we always know in a competitive market that we produce where price is equal to marginal cost. As you can see, price is intersecting with marginal cost at this point here. So we're producing this quantity Q star. But we notice that at this quantity Q star, our price is also equal to our average total cost. So at this point here, we can say that our price, our marginal cost, and our average total cost are all the same, which is what gives us this profit of 0. And if we tried to draw a rectangle, the rectangle would just have a height of 0 and therefore an area of 0. One interesting thing to note here that's going to become relevant later is that when the price is just at this bottom of this average total cost, U, you'll notice that the firm is producing where its average cost is the lowest, or it's producing as efficiently as it can. You may have noticed a bit of a pattern by now. So we can say, in general, when we face cost curves where we have the typical looking average total cost U-shaped curve here, and we have this increasing marginal cost curve here, we can say that when our P star, or our market price, is greater than the minimum of average total cost, meaning greater than the bottom of this U here, we get positive economic profit. When our market price is below the bottom of the U, or below the minimum of the average total cost curve, we get, instead, negative economic profits, or losses. And if our market price is exactly equal to the minimum of our average total cost curve, or the bottom of this U here, then what we see is that our profits are exactly equal to 0. Furthermore, it's probably not surprising that as the market price goes up, like we said before, our quantity produced goes up. And as we can see with this relationship here, our profits also go up. Not entirely surprising that higher prices are good for firms in competitive markets. On the other hand, as prices go down, we see the opposite. We see that as prices go down, firms want to produce less of that item, and they see their profits decrease.